Hello and welcome to our last section in this unit. It's 5.7 inverse trig functions integration, and this is just kind of the reverse, obviously the reverse operation of what we were doing when we were doing differentiation in 5.6. And so these are the rules that you need to remember. These a values, these dividing by a's, come from they were not necessarily in the other in differentiation because for the most part a was 1. So when we were dividing by 1 they didn't pop up in the problem. But now when we go backwards we have to take into account that this value isn't always going to be 1. So we need to remember these rules as we go through, and we're just looking for these patterns as we do these problems. So I've got a couple quick little examples for us that we will do to help us out. And so when I look at this problem, I notice that my a value is going to be, well, my a squared value is 4, so my a value would be 2. So then this looks like my sine integration, which you just need to know the pattern, with my arc sine. And so for this answer, it's going to be arc sine of x over a plus c. And that's what we get. So it's just a matter of learning the patterns to do these. Well, in this one, if a is my a squared is 2, then a would be root 2. And my x value, which was normally x, but it's 9x squared. So if x squared in this case is 9x squared, that means that x will be 3x. I mean, it seems kind of weird to write it that way, but I'm just trying to equate this with the patterns that we saw up above on the previous slide. And so now this looks a lot like arctangent, and so I would just write this. I do have to go through, and you'll notice that since there's 3 times this, I'm going to factor out, I'm going to divide by 3 to get that x out. So really I'm doing 1/3 of the integral of this function, which would be dx over the square root of 2 squared plus 3x squared. And so this is because there's a number in front of the x. We've got to take that into account. So now this looks like arctangent because it's adding, and there's no real square root in this besides with the root 2. So then it's really, I'm going to get 1/3, and then I multiply it by the a value, which is root 2, and then it's going to be arctangent of the x value, which is 3x, over root 2, and then you add on your c. And so it's just a matter of following our patterns that we saw up above, and we just need to look for them and try to figure out what we've got here. So in this case, our u value, I guess I probably should have just called these u squared and u. Our u value in this case is going to be, our u value is 2x, and so when we differentiate that, we're going to have u prime is 2, so that's going to give us half the amount we had before, or it's going to actually multiply into the x here, and it'll actually help us follow our pattern a little bit more. And so then our a value, hopefully you can see, would be 3 when I take the square root of 9. So this almost looks like our arcsecant function, except for I need a number in front of here that matches the x value. So I could rewrite this as 2 dx when we're multiplying by 2 and dividing by 2. Whoa. And then I could go ahead, let me just rewrite this whole thing here. I could write it like this and say, oh, well, I can multiply by the 2 on top and multiply by the 2 on the bottom, which gives me this. So I'm not changing the problem any, but this becomes 2x squared minus 3 squared. And so this looks a lot like our pattern that we had for arcsecant, like I was saying. And so then I just go ahead and say, oh, well, I've got 1/3, because that's 1 over a, times arcsecant of the x value in absolute values all over a plus c. And like I said, these are just following the patterns that we have established on the previous one. And this is the reverse of the differentiation. So that's all we're trying to do. Just kind of try to match these guys together with the differentiation. So then we have an example that looks like this. And so we kind of need to go through and break this up a little bit. We know that if we said that we could say that u is e to the x. And so this 2x right here, remember, is really e to the x squared, because we'd be multiplying together and then we'd have 2 e to the x as we'd add our exponents together. So you need to remember that that's really what we're talking about. If I differentiate u, well, I get e to the x dx, which becomes a little bit of a problem, which basically means that I have to divide by e to the x, which means that dx can be replaced by du over e to the x, which then when I plug that in, that changes. Even though this kind of looked like sine to begin with, you'll see that because I'm using this division that we have done before, because I would just divide e to the x across the equal sign, which is what happened here, I end up with an integral of du. Well, I'm just going to leave it as dx, but I'm plugging in if I was plugging in my du values, well, actually I think I will, I'll put in du's. I'll put in u's. So if I plug in my du, replace my dx, I'm going to get e to the x times the square root of u. Well, this is u, so I could say u. You see how this is all, it gets a little confusing when you start having all of these same and different terms together. So if I change it to du, I would end up with u times u squared, u times the square root of u squared minus 1. And so then this ends up following our pattern, not of sine, but of secant. And so, and the reason I knew it wasn't going to be sine is because it was this was my u value, this was my x value, and usually sine will have a number minus the x value. This was a number, this was a function minus a number value, so it couldn't have been sine. That would have matched more of secant. So then I will just go ahead and rewrite this. Well, arc secant, and I didn't put 1 over 1 for arc secant because a is 1, so I'm not going to bother with that since a is 1. I'm not going to bother with 1 over 1 out front, and then it's going to be the absolute value of u over 1, which I really don't need the over 1, but just to keep track of things. So I have 1 over 1 for that, and so then I would have arc secant of e to the x plus c as my final answer to this problem. And so what we're trying to do is we're just trying to relate this to what we've done before, but we're trying to get it into a pattern that we can deal with one of our inverse trig functions. And so then our final example looks like this, and you may notice that 4 minus x squared looks a lot like arc sine. So what I end up having to do for this is, because we have two terms on top, and if I could get a number over, if I could get dx over this thing right here, so if I can get dx over the square root of 4 minus x squared, well, that is our arc sine. Okay, with all the stuff plugged in. I'm not going to plug it in right now, but we'll do that in the future. So the problem is, though, I've got this x plus 2, but remember that this is all one term on the bottom, so I could rewrite this as two different integrals, which is just a way to do these things. And we could write one like that with a dx, and then we could add 2 over the square root of 4 minus x squared dx. And if I do that, then this guy right here will basically be my arc sine if I factor out the 2. This one right here, well, we get to go through and do u substitution and whatnot for it. So everything's kind of coming back together. So if I say that u in this case is 4 minus x squared, du turns into negative 2x dx, which then we get negative 1/2 du will equal x dx. And so over here for this first half, it's going to turn into negative 1/2 the integral of, well, the x dx is being replaced with du and negative 1/2, and so it's really 1 over the square root of u du. Over here, I would, on the second half, I'll factor out a 2, And by doing that, I get dx over the square root of 4 minus x squared, which now looks a lot like arc sine, which is what we'll be able to convert that to. And so over here, I got to do a little bit more work. Let's see, I'll get negative 1/2 times, now if I raise this by a power, it's really u to the negative 1/2, so it becomes u to the 1/2 divided by 1/2, so we're really multiplying by 2, and then, yeah, so we're just multiplying by 2 on that case, and so that'll take care of that part. And then over here we have 2 times this, and then we got it looks a lot like arc sine, where a is 2 and the x is just x. So we would say, oh, well, it's going to be 2 times the arc sine. This 2 comes from right there, and then this arc sine is just the rest of the function, which is x over 2 plus c. So we're almost done here. I just got to multiply by 2 and divide by 2, so I get negative the square root of 4 minus x squared plus 2 arc sine of x over 2 plus c. And that is the final answer of this. And so when you come to class, we will talk more about this stuff. But if you have any questions, please feel free to come and ask questions about this. Thank you.